Alright, welcome back ladies and gentlemen. We're moving on to 2.8, day 2 of line relationships. We're going to be writing the equations of lines that are parallel and or perpendicular to one another. And now this little blurb down here is the geometry. Basically what that says is it's going to be important in geometry to be able to talk about parallel versus perpendicular, because there's an awful lot you can tell about various shapes if you know that certain parts of them are either parallel or perpendicular to one another. Alright, so to move on to that, we have to be able to recall some line relationship stuff that we did from the previous lesson. For instance, two lines are parallel if their slopes are equal. Of course, you might say the same or something like that, but again, use whatever word suits you the best. Alright, and then here we go. Two lines are perpendicular. Now this one's a little bit more interesting, let's say. If their slopes are, two conditions have to be met. First of all, they have to be opposites. And by opposites, what I mean positive versus negative. Got to have one positive guy, one negative guy. The order doesn't matter, but you have to have one of each. And also, they have to be reciprocals of each other. Okay, sorry, that's a C right there, believe it or not. Okay, they have to be reciprocals of each other, and basically reciprocals means that they have to be flipped in relation to each other. Alright, so there's the base knowledge to move on to the next slide. Alright, so now just to practice what we just said, give the slope of any line parallel to each line. Okay, so this first example, I've got 1/6 x plus 5. And again, the mx plus b form we have right here means that the m is right in front of us, and again, to be parallel, you've got to be equal. So in this case, the slope I'm looking for is simply 1/6, the thing that I'm staring at. Okay, likewise here, my slope is again the thing sitting right in front of the x. So my slope is negative 2/3 in this case, if I want to be parallel. Okay, same basic thing here, give the slope of any line perpendicular to each line. Well again, I'm looking at my slope, which is 2/5, and so then I've got to go with the slope perpendicular. Now I'm going to introduce a little symbol right here. The slope, and I'm going to put a little upside down T looking thing. This is a geometry symbol meaning perpendicular. Okay, I like to use that to help differentiate what I'm trying to do. So anyway, the slope perpendicular to this guy, again, I want to do opposite, so it's going to be negative since this guy's positive, and I need to flip him over. So instead of 2/5, it's going to be 5/2. So then there's a slope perpendicular to this equation. Okay, likewise here, if I've got my slope here at -4, alright, my slope perpendicular to that guy, okay, again, it's negative here, so it's going to be positive down here, so I'm not writing any sort of sign yet. And then I've got 4. Now remember, this is really 4/1, so if I'm flipping that, it becomes 1/4. Again, don't let those non-fractions fool you. You can always imagine a 1, and that helps see what the reciprocal is when you're talking about perpendicular stuff. Alright, so there you go. Alrighty, hopefully you're still with me, so we can go on to writing equations of lines parallel or perpendicular to other lines. Okay, now there's a couple of formulas we need, and we've used these before. Alright, this first one here is our point slope form. And remember, this guy is basically just a big tool, and I mean that in a very nice way. That's a tool that we're going to use to get to this form over here, which is our slope-intercept form, which is then basically just our answer. Alright, so yeah, use this tool to get to that answer, and here we go. Okay, I want to write the equation of the line that passes through 4 and 9, which is parallel to the line y equals 2x minus 7. Okay, now again, this line is in a very, very nice form, at least for our purposes right now, is that this is our slope. So the slope is going to be 2. And again, if I want to be parallel, I want to use the exact slope I have. So there it is, I'm using a 2. And again, the point is 4 and 9. So I'm going to use the m equals 2, and the point I'm going to use is exactly that point right there. And remember, that basically gives me my x1 and my y1. Okay, so now I can use my point slope form, plug in y minus the y we have, which is 9, equals our m, which in this case is 2, parentheses x minus the x we have, which is a 4. Alright, now remember, in order to get this into our slope-intercept form, our answer form, we basically have two steps here. We need to distribute first of all. So this 2 distributes, giving me y minus 9 equals 2x minus 8. Okay, and then from there, I just need to cancel out the number over here with the y. In this case, it's a -9, so I'm going to use a plus 9 on both sides to cancel him out. And that gives me a final answer of y equals 2x plus 1. And there you go. So that's what that's going to look like. Alright, Alright, so let's try another one here. We're going to write the equation line that passes through negative 3, 8 that is perpendicular, so there's a little bit of a change from the last problem, to the line y equals 3/5 x plus 1. Okay, now again, first thing I want to do is figure out my slope, and now my slope, but I want to be perpendicular, and it's going to be 3/5, so again I have to do two things. I have to change the sign, so the positive 3/5 becomes a negative something, and that something is the flipped version of this, so it becomes 5/3. Okay, so now there's the slope I'm going to use, and again, basically I just use the point that I was given, not much mystery there. Okay, so again, plugging that into our y minus y1 equals mx minus x1. Okay, you don't really care if you rewrite the formula or not, but if it helps, please do. So I've got y minus the y1, which is 8, and then my m is negative 5/3. And then x, and again, since I'm going to do an x minus negative 3, I'm going to kind of shortcut this and just call it a plus 3, because I know those two negatives are going to make a positive anyway. Okay, now once I've got this far, again, I've got two steps before I'm done. First step is distribute, and distributing the negative 5/3, at least to the x, isn't so bad. It's negative 5/3 x. Okay, then pay attention when the negative 5/3 hits the 3. Okay, it works out to be a minus 5. I got a y minus 8 over there, so now I need to cancel the 8 by doing a plus 8 to both sides, and that gives me a final answer of y equals negative 5/3 x, and then negative 5 plus 8 is a positive 3. And again, there's a line now that meets those conditions from the problem. It's perpendicular to our original equation, and it's going to pass through that point, negative 3, 8. We'll throw a new twist at you here. We want to write the equation line that passes through 6, negative 4, but this time it's parallel to the line 5x plus 2y equals 18. Okay, now notice this time the equation we have is not so nice that the slope is staring us in the face. So we need to rewrite it into our slope-intercept form so that we have an easier view of the slope. Alright, so first thing first, I'm going to cancel the x, so minus 5x from both sides. Gives me 2y, and I've got negative 5x plus 18. And once I get that far, I divide off the 2. Okay, and in just a second I'm going to look at something that I like here. I've got negative 5/2x. Okay, and realistically 18/2 is going to give me a 9, but I'm not really worried about that. I'm worried about this guy right here. Alright, so once I've taken a look at that guy, I know my slope, and again, since I'm parallel, I'm just using the exact same thing. So the slope I'm using is a negative 5/2 still. Okay, and again, I've got that point, 6, negative 4, which I'm just simply recopying from right there. And those are the two bits that I'm going to plug into my equation, or I guess technically 3, depending how you look at it. But here we go. Y minus my y, in this case, is negative 4. So again, instead of writing minus and negative, I'm just going to write it as plus 4. And then I've got my slope, which is a somewhat icky negative 5/2. And then I've got x minus my x, in this case 6. Alright, again, two steps to clean up. Distribution, negative 5/2x. Okay, then negative 5/2 times negative 6. Well, first of all, I know it's going to be positive, and then 5/2 times 6 is going to be 15. Alright, I've got my y plus 4 that I just bring down, and then again, to get the y by itself, I just cancel out the 4, in this case by subtracting. And I've got y equals negative 5/2x plus an 11. And there is my final answer. Okay, hopefully you're feeling kind of good about things right now. So kind of worst case scenario here, I suppose. Write the equation line that passes through negative 1, negative 5. It's perpendicular to x minus 3y equals 12. Alright, so worst case scenario, and then I'm looking for perpendicular, so I do need to mess with my slope. The other worst case thing about here is I don't have my equation in a nice form, so I know what the slope is. So I need to clean him up first. So I subtract 1x from both sides to cancel the x term. Leaves me with a negative 3y equals negative 1x plus 12. Now I divide off the y coefficient, so it's a negative 3 in this case. And that leaves me with y equals, now watch your signs here, I get a negative 1 over negative 3, so that works out to be a positive 1/3 x, and then 12 over negative 3 is a negative 4, but again, I'm not really worried about that. I'm worried about this. Alright, so once I've identified my slope, again, in this case I'm going perpendicular, so now my slope perpendicular to that guy, positive 1/3 gives me a negative something, but if I flip over 1/3, now granted I get 3/1, but since that 1 on the bottom is optional, I'm just going to write it as negative 3. Okay, and again, I've just got that in the negative 1, negative 5 from the given information. That's what I'm going to use now in my formula, our point slope. So now y minus the y, again it's a negative 5, so I'm going to make that a plus 5, equals my slope we just found was negative 3, and then x minus negative 1 leads me to write a plus 1, and then I'll just again clean this guy up. My distribution here is not so bad because I don't have a fraction anymore, so negative 3x gives me a negative 3 right there as well. Bring down my y plus 5, lets me subtract 5 from both sides, leave me with y equals a negative 3x, and then a negative 3 getting together with a negative 5 gets me a negative 8. And there is your final answer for this guy. Alrighty, so then we arrive at the wonderful world of trapeze. So give this one a shot, and give this guy a shot as well. Alright, thanks a lot, and we'll see you in class.